Hi, today we're going to be solving this problem for Calc 1. The problem wants us to find the derivative for the function f of x equals root x minus 2 using the definition. So the first thing we're going to do for this problem is remember the formula that we need to solve the problem. So the formula is limit as h approaches 0, f of x plus h minus f of x all over h. Now, all we need to do for this part pretty much solved all of the calculus part of it. We just have to plug everything in and do the algebra. So at this point, we know our f of x because it is given to us. It's root x minus 2. That is not a 2. And the next part is the f of x plus h. This sometimes can be a little tricky. Basically, you just replace the x from the original problem, which is right there, with an x plus h. So we just have a root x plus h. Don't forget the minus 2. Now we're going to use these two. We're going to plug it into our original formula. So set number 2, we have the limit as h approaches 0. Then we have root x plus h minus 2. And then we're going to have minus root x minus 2 all over h. The h always stays as that letter. We never plug anything into there for this kind of problem or any other problem, presumably. So at this point, you may be feeling a little stuck. So the first thing to do is to look at your options, and the best option for solving this problem is to see if we can cancel anything out. So right away, you maybe notice that there is a subtraction sign right there, and we can use that sign and distribute it in those parentheses. So we're going to rewrite the first part, so root x plus h minus 2 minus root x, that becomes a plus 2. Now you can see we actually have something to cancel out, the negative 2 and plus 2. And that sets us up better for the next part of the problem. So we go ahead and rewrite that, root x plus h minus root x over h. At this point, we're going to want to go ahead and take the conjugate, which is usually what you do when you have square roots in the problem and you want to simplify it further. And the conjugate is the opposite of the part that has the roots. So if you don't understand what I mean by that, take the x plus h. Nothing under the roots will change, but the symbol's outside. So instead of putting this subtraction sign, I'm going to put this positive sign. So plus x, and I do it for top and bottom, so x plus h plus root x. And then you will just FOIL or distribute. So on the top, we're going to limit of h approaches 0, distribute this, root times root cancels, so we'll have an x plus h in parentheses, distribute that, plus root x plus h, just distribute, minus root x plus h, and then distribute once more, and we will have a minus x. Okay, once we have our numerator FOILed out, go ahead and remember this step. These two, we multiplied the conjugate from the top and the bottom, so we have to distribute that to the bottom as well. So root x plus h plus root x, that's times the original h. And as you can see, probably, this is a plus, this is a minus, and they are the exact same. We can go ahead and cancel those values out. So that is going to leave us limit h approaches 0, x plus h minus x over h root x plus h plus root x. And the reason I dropped the parentheses this one, because it makes it easier to see that there's something else that actually cancels out, and that is these two x's right there, plus x minus x. So now that just leaves us with the limit h approaches 0, h on top, h on bottom, root x plus h plus root x. And once again, we are able to cancel something else. H, that goes away. And this is a very important thing to remember, that just because this h goes away does not mean that there's nothing there. I make that mistake quite often. It actually turns into a 1. So you have 1 over root x plus h plus root x. And while that is the most simplified form, that is not the final step. So since we can't simplify it any further, we're going to go ahead and finally plug in our h value. So I'm going to go ahead and up here where there's more room, I'm going to copy that. Copy. Okay. And from there, we're not going to rewrite our limit because we're plugging it in. So we have a 1 over, it only goes into the h, not the x, so we have root x plus 0 plus root x. And that equals 1 over root x plus root x, which finally equals 1 over 2 root x. Because that's basically the same thing as saying x plus x equals 2x. You just have a root in it. This is the final answer, and that is how you solve this problem. Here are all the steps. For this problem, or this type of problem, is the definition of the limit. So this is the formula we're going to be using. That is the limit as h approaches 0 minus,